Hi. I'm here today to give you an introduction of our forensics platform that we've built at Siemens CERT over the last, I think, 3 to 4 years. Basically, we have an agenda that is quite packed. So first, I'll give you a quick introduction into Siemens CERT and what we do in general, and a short architecture overview over the platform. And then I'd like to dive into 3 topics in particular that more or less make up the platform. That's the workers, the workflows, and the user interface, of course. And then I'll try to sum it all up and still have some time left for questions, I hope. So with that, let's get right into it. Forensics at CERT. So CERT in general at Siemens is maybe one of the oldest corporate CERTs in Germany. So we've been active for more than 20 years in some form or another. Basically, we've always been a mixture of research and doing actual security operations. Right now, of course, we're embedded in a much larger security organization, whereas other teams like the product CERT, red teaming, security operations center, and all the things you usually have in a large organization. We are CERT, we do the instant response for all the companies, so all the business units and all around the world. That leads to us also being quite an international team by now. So we've currently 6 locations where we have people, and I guess this is growing over time. For me in particular, I've been at Siemens CERT for about 6 years now, working as an incident responder and a forensics analyst. And if you work at CERT for a while and you're interested in the topic, you automatically become some automation engineer. So I call myself that now as well. And since the beginning of this year, I've been the topic lead for the forensics inside Siemens CERT. So what do we do? Basically, the forensics team is a small sub-team inside the incident handling team, and we support incident handlings and incident handlers by analyzing the data and giving results, writing reports. And in the times where we don't actually investigate, we try to research and develop and extend our internal tooling. And this is part of what I'm going to present today. So how did this look in the past? So forensics is usually in the incident response stage where you respond to an actual crisis. So when threat intelligence has failed and something has actually happened, then you usually have different steps. So you will need to acquire data, you will need to prepare it, process it with different tools, and then you need to analyze that data, and in the end, hopefully have a report of what has happened that is as comprehensive as can be. And every incident handler and every forensics person usually has his set of favorite tools that all work differently. Try to visualize those with those different shapes. So everyone has his favorite tools lying around, and you're trying to use them and save the results in another folder, and then you have new results, and this all gets very chaotic. So this is the problem we try to solve in the end. So what do we want? The problem with this approach is consistency. So if you process a case today and you process another case tomorrow, you might have your tools and one tool won't work anymore, or you find a new tool. But this is all not consistent, not really documented. And of course, scalability is also a problem, since different forensics investigators will have their different tools, and you can't really compare the results of 2 different investigations if you haven't used the same tools and looked at the same data. So the approach as we envisioned it is that we can automatically deploy all the tools we have at our disposal, and this is all in a defined flow. So this is the theory. Now let's get into how we did this. So the architecture in general is we identified 3 big building blocks that we need to achieve this goal. So we need an automation backend that does all the management of cases and jobs. We need a common tool interface, meaning that for every tool we want to use, we want to orchestrate it, we want to start and stop it and look at its progress in the same way. So that's why we want a common interface for this. And on top of it all, we need a user interface so we can actually look at what has happened. We want to see if all the tools run. We want to look at the results, and we want to document what we find. So this all in a box is called SiERRA. And if anyone asks you, it's the Siemens Extensible Rapid Response Automator. So now you've heard that. Some nomenclature before you get into the details. Basically, our most ground building block is the case. A case just encapsulates everything we do in the investigation. And a case usually has evidence items. And as evidence, we define everything that we load into the case because we found it somewhere. But we also define as evidence anything that comes out of tools that we run over those first pieces of data we found. So this gives us the ability to compute a hierarchy of evidence, if you will. So we will know this report came out of this tool and this was fed another piece of evidence. So we can trace that back to the initial evidence and with that to an initial asset that we investigated. Then what we also want in the case in the end is a finding, and findings we define as some relevant piece of information we found, hopefully explained why it's important and why we think that this is part of the case and of the investigation. On the more technical side, what I will refer to as workers is basically all analysis tools that will report to a central job broker and tell that broker what kind of job they can do and what input they need for that. On the other side, a job is a request for a certain worker to do some actual analysis with a piece of input parameters. We also use this job object then to track the job status and manage all the jobs. For the tech stack, nothing too exotic, I think. So on the bottom, we of course need storage for all the data we will process, and we're using S3 compatible storage there, but we have that locally. And for database items, so smaller pieces of information that we don't want to store in a file, we use Elasticsearch. Then all the workers get bundled usually in a Docker container, and there's some sort of Python running in most of them, but that is not a requirement. You could basically write workers in every language you want as long as it can talk to the API and to the storage. For APIs, it's also no surprise. We use Fast API basically to manage cases, to manage jobs, to manage evidence, nothing too special there. And for the user interface, we use Vue.js, which is a pretty nice way to implement most of the things we needed, and is also very extensible. Okay, then let's get into a bit more detail with workers. And I'd just like to explain this with an example. So let's say we have Hashcat. For one's not familiar, Hashcat basically is a tool to crack passwords by trying dictionaries until you find the right hash. And this is a command line tool, so you can already use it pretty well. But we will now want to wrap this in a script so you can use it as a building block. Basically, we have defined a Python library for this, which we call the worker library. And this already extracts away the backend communication, the file handling, the job management. So if you're implementing a worker for Hashcat, you can just use this library and it will do most of the work already for you, and you have just to define how the tool is actually used. So you will want to run the analysis over the data. You will want to store the results back in the case. You can also decide to look at the results and alert the user about suspicious things that might be there. You might want to write something in a database for later use. And you can, of course, report progress and status of your job. So Hashcat is usually a long-running process, so it makes sense to report how far along you are in the process. As a bit of technical detail, we use JSON schema for that. So workers will report to the backend in JSON schema form what kind of input parameters they need. So for example, for Hashcat, if we want to crack Windows passwords, we will need the SAM registry hive. And there are some other parameters defined here. So for example, the user can give extra passwords that should be tried if we already know some. Or there's a Boolean you can check if you want to do more brute forcing at the expense of more processing power. We take this JSON schema in the user interface and automatically transform it to something you can click on and pre-fill it with values from the case. And we can also use this, you can see that here, to see how the job is progressing. And this is from another worker, but basically this is the status reports that workers can give while they are running. So you always have an overview of what's happening. That's it for the workers. So let's get into workflows. Basically what we have now is nice, and we can start different workers, but still a lot of manual clicking if I want to run all my tools against all my files that I have. So what we really want is some way to define which workers we want to run and which input data, all based on some initial evidence we have. So as an example, we start with a disk image here, and for that disk image I want to hash all the files that are in it, and I want to check if the hashes check out for some IOCs. I might also want to run other tools over the image like SiERRA, or I might want to extract files from that image and then use different other tools to process them, and that will spit out more files, and then I want to, again, check this against IOCs. So there's no problem you can solve with a bit of YAML. So we came up with this definition language. It's a bit like a CI definition. And basically what we have is the initial parameters that we define over here. So you have global workflow parameters like the input image in the example. And then we have workers that use those, like the extract artifacts worker. That's the first one that uses the initial evidence to extract files. And then in this example, we want to further then process event logs that came out of this extraction. And for this, we can say this job will use the output of another worker. And this automatically also defines the order of execution. So in this case, we know we have to use this one first. And after it's finished, we can use the output for the next worker. So this also implicitly defines parallel execution, but it also defines the dependencies. So further along in this example, let's say we have extracted these files. So now we will need to start the next one, the event log parser. So looking at our recipe, we should now use the output of that artifacts worker and put it into the event logs parser. So that's all this. But obviously, there's much more that has been extracted here, so we can't just pass this along to the next worker. And what we do here is we also look at the job descriptions of the event log worker, and the event log worker says that it only wants to process EVTX files. So we filter this list down and just start the next job with this EVTX file as input. The same works for other workers as well. So we always combine the output listing with the definition of input that the next worker wants to automatically filter this down. And this works surprisingly well. In practice, it might look like this. So this is an actual workflow we use for testing. We're starting with actually a zip file up here that has some artifacts that we collect with an agent. And then a lot of jobs are running. And if you look closely, you can see that we have started to use sub-workflows. So we have better reusability of the workflow definitions that we have. But basically, it's just like I said, so we start one workflow and it will just process the whole image with every tool we have. Okay. Then let's get to the user interface. I have prepared some screenshots here, and unfortunately they're a bit small, so I hope you will be able to see anything. So basically we start with the case overview, and here you will have the list of all the assets in your case. These are the base evidences. And you can mark if they are still pending or if investigation is finished with them, and you can also mark them as compromised or clean or some other state. And you also have some notes here. If there's ever anything you need to note, you can also save that in the same case. One step further, when we click on an evidence item, you can see there's some basic information about the hosts. In this case, it's a Windows 10 host. And this white list of evidences here is everything that the workers have processed that came out of this initial image. So everything in all the steps that came out as a result will be displayed here. So this is a dynamic list of everything that has been created. And now obviously there are different kinds of information that has been extracted in different formats. So we implemented different viewers for those. Before we get to those, maybe you remember, workers can also alert us to things they found while processing. And these automatic findings are also displayed if you scroll down a bit. So for example, we have some worker that looks at certain event logs for PowerShell scripts. And it was, there's strange base 64 in those PowerShell executions. Maybe you should look at that. Or we have another worker that looks at process and service executions. And if it finds, for example, PSexec, it will notify us here that that might be something to look into. And basically, we've defined different things that workers will alert us automatically. And this mostly also already gives us a good first jump into the case when we start working on it. Okay, let's get to some of the views. So this worker, for example, writes Markdown reports. In this case, for auto runs, we'll do a bit of virus total lookup and other things. But basically what you can see is that the Markdown is just displayed in the browser. Not that surprising, I guess. We have another worker that does CSV as results, so tabular data. And this will be displayed in a table that you can also filter on. But that's also not that interesting. So let's get to some interesting things. We have the possibility to display tree views. And we use this example, for example, for the output of a worker that parses the MFT for us, and it will write a database with all the MFT entries, so the file system entries. And we can display this here as a nice tree, just like you're used to, with the addition that you can also filter and search really, really quickly inside this tree. This also works for registry and other kinds of tree-like data that you might have. And then finally, there's a timeline view, of course, because no investigation is possible without having timelines. It's not so different to other timelining tools, I think. So we have a histogram where most of the interesting events are, and we can filter and of course, select special dates where we want to start looking. What's kind of cool is we also have one-click filtering for tags in this database. So we usually apply Sigma tags and also the inbuilt Plazo tags, so you can quickly filter down and look at events that have been tagged. We can also see we have some predefined searches here that we usually use that you can also activate with one click. So something like everything that has an execution flag or things from what's here, browser activity, Windows event logs, things like that. So now the most interesting thing, I think, is documentation. So everything you can see in the interface, you can document by double-clicking on it. And if you double-click on something, you will get this dialog. Do you want to save this as a finding? And basically what happens is that we look at what you clicked on and already pre-fill a text field with markdown text with what you clicked on, and you can then extend this and describe why you think this is relevant, for example, and basically can use all kinds of markdown to emphasize what this finding is. So finding is linked to an asset and to a timestamp. And this means if we have collected a few assets, a few findings, we can then look at our findings view and get a chronological list of all the things that are relevant in the case. We can also use like a time divider here, so to get a better picture of how much time has passed. But basically this view in the end allows you to tell the story of the case just as it happened. And in most cases, this is enough to use this view in the end to have a nice report of what has happened in the case. Okay, now I have been quicker than I anticipated, but that's fine. Summary. So I think we really increased the quality of our investigations by using this automated approach instead of using manual tools one by the other. I also really like the low-effort documentation we get by just saying, oh, I think this is relevant, let's click on it and document it, and maybe it's not relevant in the end, and I can just delete that finding later, but I have it here, and it can't be forgotten. And of course, collaboration is vastly improved by having a web-based system instead of every analyst using his local computer and using grep or his favorite text editor to look at log files. It's much less collaboration even possible than having a system where everyone can click around in parallel and share their findings. So for flexibility, we've also found that reacting to new challenges we see in a new incident is quite easy, because we just need to write a worker that automates whatever we haven't looked at in the past but want to look at now. And once we have implemented this worker one time, we can include it in the workflow. And after that, it will be run for every case we ever have after this point. So we are very quick to adapt to new challenges or new data sources that we want to process. I also think we've pretty much used all the viewers we need. So we also have a few more exotic viewers, like for JSON data, we can also display this in a nice way. But usually what you have in the end is either a text report like Markdown, or you have something tabular or database. So this has been shown to be a very good tool to look at pretty much the whole case. So we rarely have the need to download files and look at them in separate tools. So usually the web interface is enough for the whole investigation. And what's also nice, of course, is the whole thing is based on Docker, so you can basically take it anywhere. You can run it in the cloud. You can run it locally. I even have it on my laptop here, so it works pretty much everywhere. And if you need more processing power, you can just copy it to a server and have more power there. It pretty much works everywhere. Okay. With that, I'd like to thank a few people. First and foremost, all the authors of open source forensic software. In particular, the Log2Timeline team, of course, because timelines are important and very nice tool. But also Joachim Metz, who pretty much wrote every parser you can think of. And the Sigma HQ team for all the Sigma rules that are also very helpful when you process a database. But of course, I'm sure I've forgotten a lot of other people that also contributed very cool and important tools. And from our CERT side, I'd like to thank Stefan Berger and Jonas Plum. Some of them might be in the audience here. Basically, they started this project with me and have contributed a lot to the success of it. With this, I'm through. So if you have any questions, I think we have some time now.
So I'll start in the front.
Well, hello, is this turned on? Thank you for your talk, and congratulations on automating so much of your workflow. That must be really nice to work with. I was wondering, what are some measures maybe you implemented to cope with the plethora of information? You mentioned, once you implement some kind of other tool, you'll run it in the future forever. So even increasing more and more the data each scan will produce. How do you cope with all of this information, and what are some strategies you have there?
I think the answer is more automation. I already alluded to that the automatic worker alerts are a big factor in where we start our investigation to see where it leads. So if you have more data, you can't look at everything, but you can usually code something into the worker to already alert you if there's something that might be fishy going on in this report or in that report. So start there, and only if you can't find anything automated, then you need to dig into all the data manually.
Hi, congratulations for the presentation, very nice. Just curious about the input of data into the platform. You show in one of your slides the analysis of image of a file, but you have a worker to communicate with some live forensics like GRR or something like that too?
Yes, we do. So this is still in development and not live yet, but basically we have an initial worker that can talk to different EDR APIs to gather data that way. But this also, in a big company, you have to have a lot of clearance to do things like this. So this is still in the development stages.
Thank you, Demian, for this great presentation about the automated CERT application. So I was coming from the security background, I'm having a bit skepticism. So I want to ask you specifically, what are the downsides or the disadvantages of using this method or application?
Well, obviously you have an automatic workflow that will just do the same thing every time. And it's a bit harder to change this on the fly, to do things differently just this one time, if it's necessary in the case. I think we're mitigating this because we can easily adapt it with new workers or just change a workflow. We've also had a case where we adapted the automation to run a slightly different workflow in a certain case. So I've been hand-waving over a lot of stuff, obviously. But basically, the automation starts when we get data from our collection agent. And we can, for example, look at in which case this data came in. And then, depending on the case, we can do something different than usually. But of course, it's still a bit more work than you having all the data on your laptop right now and then just running a tool you want to run right now, which you can still do in some way because you can download everything that's in the platform to your local PC, for example, to apply more filters in Excel if you like that more for a CSV. But I'd say this is a slight disadvantage that, of course, by defining our workflows, we have defined them, and adapting them is a bit more, requires a bit more work than just doing it when you're using one tool after the other manually.
Yeah, perfect automation. Congrats. My question is, do you keep the records of past findings? Is it possible to search for, retrospectively search if there something in your case right now that you see already in the past, like 2 years ago?
Interesting question. So it is possible. So we keep those, and those are also in a pretty concise format, so we can keep them for a long time. But we haven't implemented a way to do it automatically yet. So we do have them. You could probably grab for them even because it's all in a JSON file. But yeah, that's room for improvement for automatic searching. Yeah.
So mine is probably the last question. I don't see any GitHub link or anything in here, so you keep it for yourself, obviously. But we also have automation needs. Have you come anything across which you could recommend, which is, of course, not as good as your solution, but something that prevents us from starting from scratch?
So first of all, yes, there's no GitHub link. We have thought about open sourcing it, and it's still not off the table, but there's a lot of processes and things to do before that can be a reality. And some of the parts of the system, of course, are very adapted to Siemens and all its structures and APIs. So yeah, I can't be that optimistic that it will be released in the near future. Probably the most simple answer is the tools that Google uses. So there's DF TimeWolf and as an automation framework, and TimeSketch and Plazo, of course, that I think are already automated using DF TimeWolf. And of course, I think it's also a Google product, Turbinia, that also tries to go in the same direction of automating workflows based on evidence items. So those are probably the open source tools I'd recommend.
Okay, that's time. So if you have more questions for Demian, catch him out in the hallway. So thank you so much for coming. Please give Demian a big round of applause. And